everyone. From first week, we learned about how can we use the Linux with the C program, as well as the concept of the basic computer structure and systems, right? And we already learned how can we make our own directory and how can we make our own C codes and save and check in Linux, right? In this video, finally, we will learn how can we execute the hello.c and what happens and why when we learn the hello on our own system. All right, so if you are not familiar with how can we code, save and check hello.c in Linux yet, please check the past video repeatedly and please familiar with the usage of the code, save and check the hello.c in Linux. All right, so in a previous video about the simple program, we checked from step 1 to step 10, right? Okay, in this video, we will go to the next step. How can you execute our hello.c code? Okay, so what is the execution? The reason why we program in computer, we want to the order or ask some mission to the computer, right? So after compiling or that means execution, computer can do the mission instead of us, right? So when you check this code, that means please print the hello everyone string on the monitor, right? So to execute this program code, we should know how can we use the execution command in Linux. Okay, so from the first week, I talked the difference between the Linux and the Windows, right? So different from the Windows, Linux can only recognize and understand its proper command from the programmer. All right, so the click is not familiar with the Linux. We should type each command for each proper mission. Okay, so we should learn simultaneously with the computer systems concept. So if you type your own hello.c, we can check the tracing of the lifetime of the hello program from the source code to the executable object program. So please take photo of this screen and periodically check this photo with yourself or by yourself, because these are very important and these are related with computer structure and systems concept. We already type hello.c, that means source program, and the data type is text. But inside of the computer, the many kinds of the hardware and software programs can operate from the source program to the execution file. All right, so first step, the pre-process program translates from hello.c to the hello.i. That is the modified source program, but still the data type is text. Second program is compiler. As a compiler, the compiler recognizes the inputs hello.i file and then output the hello.s. That is the assembly program. So assembly program is not familiar with the high level programmer because they are short of the English level grammar and more similar to the machine language level. But still, the data type is text. But after third program, assembler, the source program translated hello.o. So hello.o is the locatable object programs, and the data type is the binary. So only 1 or 0 the bit patterns are existed here, but we cannot understand. We don't need to understand or recognize these labels because we only type the source program and execute and just to check the our mission on the screen. But my point is, in the inside of the computer, there are 4 steps of other programs cooperation from the original one to the execution. All right, we don't need to consider or recognize it, but the reason why we learned this lecture, we want to improve our capability of the programming on top of the hardware and software concept, right? So I mentioned the other 4 steps of the translation programs such as preprocessor, compiler, assembler, linker, all right? So linker is very, very important in C programming language because hello.o is from our own source program, right? But printf.o is the standard, the shared, the system level functions, right? So linker can't merge the programmer part and the standard part, right? But sometimes we can meet some linking errors in C programming. So we should know it about linkers function and roles. We will check in detail in the linker part, so don't worry about it. Okay, so finally, hello file. That is the no extension anymore. Extension means .c, .i, .s, .o, right? But final execution object program has no extension anymore, right? So hello and binary file can be generated finally, all right? And if we type source program hello.c, in fact, computer can has the mapping table from the alphabet to the integer. For example, even though we put include, but I is mapping to 105 and mapping to 110, C mapping to 99. So why did computer translate from each alphabet to the integer number? Because of the generalized concept of the programming all over the world, regardless of the alphabet or other country languages. They can be shared the integer each number, such as the ASCII code, finally regardless of the computer the status. So the ASCII text representation existed for the letters to the integer. And second reason of the ASCII the text representation, because to speed up the execution finally. All right, so we will cover in chapter 6 maybe why can we distinguish between string, the character with the integer as well as the float for the memory part. So we will cover step by step, so don't worry about it. So I think as a beginner, most students are new about this concept, because in case of the R or Python, we don't need to consider about the hidden, the 4 step or 3 program parts of the preprocessor, compiler, assembler, linker, right? We just type and the computer interpret each line and get the result quickly, right? So interpreting level languages, we don't need to consider about computer system level, the hidden executions, right? But different from the R or Python, C program language is one of a compilation system language. So different from R or Python, C program can be recognized wholly from the first line to the ending line with these four steps, and then programmer can execute our code. So not interpreting mode, but compilation mode, right? So we should know how can the hello.c program can travel from the first step to the execution steps, okay? So as I mentioned, that means the compilation system. So we only type code program high-level C programming with the English grammar only, right? But if we execute our C codes with the predefined commands, the computer can translate our source code to the hello.i, hello.s, hello.o, and finally we can get the hello execution file. How can we execute our original source code? The commands start with GCC. So GCC is one of the names of a compilation system, and we want to compile our C codes with the execution file. All right. So our execution file can be translated object programs, right? So GCC-O execution file name hello.c. So you can change your file name and you can change execution file name too. So it is up to you, all right? So flexibly and freely change other names with your own time on top of the flipped learning with the pause of our video, and then you can have your enough time. All right. So even though my video clip, each video clip has only 25 or 30 minutes, but I recommend you use your own file name and your own exercise with the pause of the video clip. So finally you can spend your own time, at least 2 times of our video clip. So around 1 hour or over the 1 hour time, okay? So GCC-O hello.c, and then you can execute hello execution file name. So that slash, that means the current directory, all right? So finally we can get the final result of the execution, hello.words, all right? So we can exercise 2 steps in the Linux together, okay? So as I mentioned, you can check your own file. The file was made, but this file was not compiled yet because there is no execution file in here, right? So sorry, bothering. So in this case, GCC-O hello. Hello means the execution file name, and we want to compile our C file here, right? So you should memorize this command for execution in Linux of C. Okay, so GCC-O, that is the alphabet O, not number. Okay, GCC-O hello execution file name and our own source code name. Okay, and then enter. So there's no error here, right? So we can check our execution file too with ls. So there are execution file name and our original file, right? And we want to execute our execution file finally, right? So that means current directory and execution file name typing. And then hello with my first English name directory, right? But there's no the next line, the special keyword, right? So the Linux default comments continuously start with at the end of my string. So we can modify this one. So we can open another Linux, and then we can compare. All right. So we can go to my English name directory and we can check this one, and we can modify our hello world. So we can go to the at the end of this string, and then we can put with I new line. Okay, so /n, and then we can save esc:/wq exclamation. All right, and then we can execute. Okay, we can change execute file name hello to and hello.c, and then we can check the two execution file here, right? So if you execute this execution file, you can check these results. But if you try to execute another execution file here, current directory and hello to, all right? So please compare the result. Hello with my first name directory with the new line, and then the default command of the Linux can be started with the next line. All right. So similar to the hello.c file, we can complement our C code at the end of this semester with the contents of the computer structure and systems, such as the system programming. So it will be a little difficult soon, all right? And then we can execute our own original file with the execution file name, all right? Okay, so after these two steps, finally, as I mentioned, we can get our own the sequence of the low level. That is the high level, right? So high level means we can type on top of the common sense of the English reserved word, right? But different from the high level language, a sequence of the low level language is similar with the machine level instruction. So if you want to check the hello execution file content, you can check with the vi2, but we cannot understand it because it is related with the machine language level instructions. All right, so compilation system can be explanations with this figure. With the preprocessor, the computer can recognize the predefined header file, and with the compiler can make the output of the low level machine level instructions. And then, as I mentioned, assembler and linker can merge our own file with the standard one. All right, so finally, if you want to check your behavior from your behavior to the hidden the computer structure and systems, if we type our C code with our keyboard, finally the execution file can be stored, saved in our memory, and the the memory and CPU, such as the hardware components, can operate each other and print out the results in the screen. All right. So finally, we can check. So please take Porter this compilations system, and then periodically check this one too for yourself. All right. So compilation system can have four defined another programs. All right. These are programs. These are programs, not hardware. All right. So finally, the execution file can be stored in the hardware component, such as memory, register, and so on, as I mentioned. All right. So how can you optimize our program performance with the memory concept? We will touch in chapter 6, and we can understand linking time error in chapter 7. And we don't need to study the security concept in this lecture, but if you are interested in the security concept, you can check the chapter 3 all by yourself. All right. So please understand the first step, and then finally at the end of the execution, the processor, such as the CPU, can read and interpret our instructions stored in memory, as I mentioned. All right. So that's can be covered in the sub chapter of the chapter 1.4. So if you have the computer systems English textbook, you can also read the sub chapters 1.4 processors. CPU can read, interpret instructions stored in memory concept all by yourself. Okay, so we already check the Linux the execution methods, right? And then we also check the shell, the can wait for the next comment for the programmer, right? So the cursor can be named by the shell program. So shell is the another application program. The program name is shell. So shell is the command line interpreter. So as I mentioned, shell can recognize each command from the programmer, and then the shell execute each command based on the programmer's the command typing. And then after executing of the commands, the shell command proponents also can wait of the next the programmer's comment. All right. So please remember and memorize the proper command for proper rows of the command, and then shell and prompt can execute the proper one all by yourself. All right. So in this video clip, we learned about what is the compilation system, and what is the first steps of the compilation system, and the final execution file can be executed with the CPU and memory. All right. So please refer our video clip and repeat our exercise all by yourself. Thank you for listening. See you next video clip. Bye bye.